So I am Robert Treat. This is managing databases in a DevOps environment. I left it on the screen, so I assume that you all are in the right talk or couldn't find anything better to do. Either way, that's fine. Who am I? I am known as @RobTreat2 on the Twitter machine. I have a blog at exilla.net. I probably will put my slides up there, although I say that at a lot of conferences that I don't. But these slides actually are already on SlideShare, so I feel like I have at least potentially accomplished a goal when it comes to sharing the slides. So you can find me in those places if you have questions afterwards or whatnot. More relevant probably to the actual talk, I work at a company called OmniTI. We do sort of large-scale operations, helping people both consultancy-wise, we do development and things like that. My particular portion of that is database operations, or at least sort of what I call database operations. That's a nebulous term, but the types of clients that we tend to work with are usually highly scaled, often have to deal with big data, and have pretty heavy transactional workloads as well. Luckily, that gets us a few buzzwords in when we try to describe it, so that works good as well. The real point of that being that we tend to work on things that are really important for people, right? Mission critical, and sort of heart of the matter, at least how I look at it with data and whatnot. So that's sort of the background I've come from, and a lot of those shops have moved towards this thing called DevOps as sort of a culture or a way of working. And so having worked in different shops, this is sort of, hopefully will be an amalgamation of best practices on ways to either get this started, or if your boss has come to you and said, we're going to be doing DevOps, it might be good to ask him what he really means by that, but these are probably sort of some ideas to have in the back of your head, things that you probably should want to be accomplishing, or big red flags on what's coming down the pike, and you should be aware of that in case it really doesn't fit well with you. So that sort of leads to a question of what is DevOps? There were a few folks in the crowd, they said that they think they're in DevOps shops. It means different things to different people. I've often heard it described as sort of putting development into your operations and the attempt to make something really delicious. I don't disagree with that necessarily, but the way that I usually look at it, more importantly, is to put operations into your development. And for those in Portland, this is the Old Dirty Bastard donut at Voodoo Donuts. It's very delicious if you ever go to Portland. I strongly recommend it, especially after 11 p.m. So that, to me, that's the tastier treat. I really like the peanut butter cup style of getting dev into the ops, but I like the other way around. I think that's actually more important, right? Getting an operational mindset to your developers. But either way you look at that, depending on which side of the aisle you're coming from, the goal really is to try to do some kind of mind meld, right? Bringing these two sides together and getting people to work together and really make something awesome. But what I found also is that when people try to do a mind meld, sometimes it's something a little bit off, right? So it sounds like it might be awesome. We've got chocolate and we've got peanut butter, and then you throw DBAs in the middle of DevOps, and now you have banana cream peanut butter Reese's. And I'm going to let you guys decide how delicious you think that is. I do think there is room, though. There's a lot of things to embrace in the DevOps movement. And so however you're putting it together, there's definitely some aspects of it that I like. And I think there's things that we, both as a community as DBAs, we should be probably trying to embrace and push forward some of these things. But I would say this is not a talk about DevOps, really, right? This is more about sort of understanding where databases fit into that need. So I'm not really going to preach on what I think DevOps is. Instead, what I'm going to do is just sort of make up my own definition of what it is and lay out some of the pieces and then tell you where things fit. That's how I roll in my talk, so that's what I'm going to do. So I'm going to sort of boil down DevOps into three things, right? The first thing is going to be configuration management. You've probably heard a lot of talk about that if you look into DevOps. The next thing will be monitoring. I think it's probably the most critical component of the whole DevOps thing. And then the last piece of DevOps is really about software development, right? The process of actually writing code and getting it out into production. And so to me, like, those are the three big things of DevOps. And if any of you are actually into DevOps, I've probably offended you. I haven't launched into your particular niche of it, and I've done the wrong thing. But it's a Postgres conference, so I probably have not offended so many people here. When I did a similar talk to this at Velocity, and there were many more offended people. But Anyway, so getting on to the part about databases and DevOps, right? That's the key thing we're here for. The first thing I really want to talk about is configuration management. Right? How many people are familiar with the idea of configuration management? All right, so most of you. How many people actually use configuration management? So the Heroku guys are like really proud of this. They're like, yeah, that's what we're all about. So I kind of like configuration management. I know a lot of our sysadmins where I work are very happy talking about that kind of thing. And usually people look at it, they talk about things like Puppet and Chef and doing system automation and spinning up nodes and it's all magical and everything's great. And you know, automating deployment of machines is really good in a lot of cases. But on the other hand, I tend to think it gets a little bit overblown at times. You know, you can automate things in a way that, I'm not saying it's not an improvement, but it might not really be, you know, the most critical thing, the thing that you're really looking for, right? So if you come to me and say, we should do configuration management, we get system automation, I don't think that's terribly exciting to most DBAs, right? It's not the thing that gets you going. And the reason for that I found is for most people, if you're a DBA, a lot of you have like one database that you're really in charge of, right? Like there's the master database, right? Or production, or they give like these really single solitary names, and that's the one, if it goes down, like all hell breaks loose and, you know, the president calls you on the phone and says, why are you destroying my business, right? And so that's what you really focus on. And for those folks, like you really don't need system automation, right? You're not going to just spin up a new one of those every week. It's just, you know, it's not the thing that you have to do. So having a large tool set that you have to learn doesn't tend to excite most of the folks, you know, when I talk to other DBAs out there. But I would say if you sort of turn your back on configuration management, if your shop is moving in that direction and you say, you know what, we don't need it, like go do your web thing with that, like, you know, spin your Apaches and be happy, but leave my database alone because it works and you'll mess it up. I think that's really the wrong approach to things, right? Anytime actually where when you put up a wall between what your operations folks want to do and your system administrators want to do and how you're managing a database, ultimately that's going to lead to trouble, right? So rather than sort of fight that battle, I think it's better to figure out what are the things you can get out of doing configuration management and sort of embrace those and see the benefits there, right? And I sort of start with the idea that even on one box, right, if you have your big Postgres server and it's sitting there and it's, you know, doing your thousands of transactions, you still have a lot of things that you have to configure, right? There are database configs, there's cron jobs, packages, scripts, you know, just all kinds of different things. You might, at some point, you put up PG Bouncer, so now you've got that process running on the machine. So there's just a lot of stuff that you have to deal with, right, and to keep track of. So having so much stuff to configure, it's good to have processes to sort of manage that configuration piece, right? The way that I like to sort of have as much document as I can, right? When you do config changes, everybody should know what the config files are. When you change a setting, that should be, you know, documented someplace as to what these things are, so that people understand why you're making the changes you're making and how to apply them, right? And if you're not going to document it in some fashion, you do at least need to have it be reproducible, right? In the event, you know, God forbid that something does happen to that big important database, you need to be able to set the thing up again, you know, and if you go from backups isn't just having the data, right? It's a pretty important piece, and perhaps even the most important piece to actually have a backup of the data, but if you don't have backups of your config files, you know, whether it's system stuff or, you know, even just like PostgreSQL.conf seems like an obvious one, but if you don't have those kind of backups, you can bring up a new database, but then, you know, you're back to square one tuning, and probably it's not going to work, right? Or at least you're going to lose a lot of time sort of recreating that stuff. And the more pieces that you have, you know, think about things like if you've changed, you know, the default shell for the Postgres user on a system, right? Well, do you back that up, right? Do you have a record of that somehow? Or are you going to have some cron job that like magically fails because now it's running in a different shell environment than you thought it was going to, right? Because you tried to rebuild this on a new system and you didn't really have documented what you needed. The other part of this is even in a well-configured and documented system, you know, things are changing, right? As you do tuning, as you have workload changes, as data gets larger, you have to change those kind of things. And knowing when those changes occur is very critical, right? Being able to track those, get information out of when things have changed and trace that back to things that are going in your environment is definitely very critical, right? And all of these sort of configuration management tools, they're all there to sort of help with that goal, right? They usually don't scream about that. because having like an audit trail, I guess, doesn't sound terribly sexy as like spinning up like 100 web servers in 10 minutes, right? But having an audit trail is actually far more important in most of the scenarios that I find that I get called in on and that people are really concerned about, right? If it takes you an hour to spin up 1,000 web nodes, for most people that's fine, versus 10 minutes. But if it takes you an hour to go back and find that a setting got changed, which is now throwing off your query plans, that's pretty critical. That can cause a lot of trouble. So sort of embracing the tools and letting them help you with that kind of thing, I find to be very important. And if you try to break through the hype of the automated thing, I look at configuration management. Those two words in and of themselves are, systems automation is a whole different thing, right? A configuration management tool should be about configuration and managing it, right? So look for how your tools help you do that, and then figure those pieces out and make that work for you, right? So, because even without the automation, it's going to be valuable to have these things in place, right? Again, tracking changes that occur to the environment. If somebody makes a change to config file, does that get checked into Subversion and send a notice to people, right? I love systems that are like that. So we all see an email that comes in. Even better if it gets graphed someplace, right? The emails are critical so that everybody on the team knows what's going on, right? You don't have the rogue actor that's like, I'm pretty sure this needs to be switched. I'll just change it and see what happens, and then I'll change it back if it's bad, right? I mean, if you have that guy on your team, you have a lot of problems, not just this one. But figuring out that that's what's going on is a lot easier, when you're notified of those things. The other thing to consider about this is, I talked about this one big database, and I think in this day and age, most people who have the one big database is very, very large and very important. It's actually probably more than just one database, right? Just as a basic rule, you probably have a failover, hopefully. But nowadays we're getting to see more and more of this sort of multi-tiered complexure thing. We've said that Postgres 9.0 and 9.1 now, you can scale up 10 Postgreses in a minute or whatever. Everyone's touting sort of the replication pieces. Well, the better the replication systems get in Postgres, the more people are going to expect you to make use of them, right? And that means all of those things that you set up for your one big database, you're actually going to have to set up again, right? And there's all different use cases that you can have for this, right? I mean, the failover is sort of the first step. But if you have read slaves or you have specially tuned ones for reporting things, doing developer machines, right, staging environments, all of those different cases where you need a database to sort of empower people to do their job, those probably fall on your shoulders at least somewhat, right? Maybe they don't have the uptime guarantees. A staging box, usually people aren't so concerned if you have to restart it in the middle of the day. Okay, we can live with that, but on the other hand, it still needs to work. And when it doesn't, people will tell you it's not a production thing, but if it doesn't work, you've blocked all your development, right? Now you can't get things out into production. So it is still pretty critical, even if it's not as critical as the actual production, right? And every time one of these needs comes up, someone is going to call you, right, to say, hey, we need this database going, or we need this refresh, we need new data on here, can you rebuild this server for us, that kind of thing. And so you end up sort of reconfiguring the same things, especially in the cases of these slave machines, right? You need your tuning to be, if not the same, I mean, you probably try to start with a base that is very similar to production and then figure out where are the cases where I need to change that, and then I have to document it, right? If you're going to rebuild a new system, and maybe that's like a weekly thing, well, then you better know, hey, every week when I rebuild this, I need to make sure that I get the right configs in there. And we see those cases a lot, and people, for whatever reason, they don't think about that. The first time it ever happens for someone to say, oh, you know what, I forgot to switch that flag on when we made that snapshot of the database. It's like, well, you're doing something wrong. That's the case where you can solve that problem using configuration management tools, right? As you look at this, and at this point, not everybody has those problems of having a lot of databases and all that kind of thing. But I think it is worth asking, do I have multiple databases? Do I project that coming? And in those cases, how long does it actually take you to stand up a new copy of your database, right? It may seem like it's really quick, and most people measure that by the time it takes to either do PG restore on the data, and once that's done, I'm good to go. Or they look at it like, well, it takes me this long to copy the files from the backup server onto the new one, and then I just start Postgres and everything's good. But that's really not all there is to actually bringing up a new service, right? Putting up a new database, again, it goes back to configs and, do you need a pooler on there and get the right ports and things and that kind of stuff. So the more you're doing that, that takes more time if it's not automated. You have to at least remember those steps, so you have to document what those are, and then to actually do them takes more time. And even once you've done that, right, there's a sort of confidence you need to have that you've actually done it correctly, right? And those little things like different shell environments, or maybe you need a custom path. We've had cases where we need this version of tar and the default one's different. So we install our version someplace else, and then we have to make sure that the path is set so it sees that version of tar in the programs where we need it. There's just those little things that people tweak, or like you change like SHM max is a common one. People have to boost that up. And far too often, people will just do it on the command line. They start Postgres, it's working. They're like, wow, I'm good to go, right? And then they forget that when you reboot, it's going to go away and your database isn't going to start, right? And even if you do that, when you go do it on the slave, did you actually document anywhere that you needed to do that? If you put that in a configuration management system, you already have the template for here's all the configs I need to bring up the next machine, right? And so it saves you just all kinds of time in those situations. So the mechanics of it can be different depending on which type of configuration management your company is trying to use. But the idea behind there is there's definitely a lot to like and embrace, and it will actually make your job easier in a lot of ways. The other thing, or the next thing I want to discuss is sort of this idea of monitoring, right? Monitoring is sort of a funny thing in DevOps, right? If you ask, well, okay, what should I be monitoring? And then the official DevOps answer is that you have to monitor everything. Right? Like, I mean, anything you can think of should be monitored. There should be a graph for everything. If you don't have millions of graphs, you're just not DevOps enough. And that's probably a little bit overblown. I do like to have a lot of monitors, right? I say always start with the basic stuff. You just look at a system. What do you want to monitor, right? Disk I/O, CPU, network traffic, just sort of those basic things. Most monitoring tools that you set up are probably going to already have built-ins for that kind of thing. So you don't have to go crazy out of the box. If you don't have those kind of monitors, though, that should be the thing that you do. I guess I'll say on Monday when you get back to the office. You don't have to do it over the weekend. But come Monday, by that time, I expect you all to have contacted somebody in your organization to say, hey, we need to set up some monitoring stuff. On the database side, there's also all kinds of things you can set up. I always tell people to start with transactions per second. Not that it's necessarily valuable in any way, but it's the biggest vanity metric for all database people. Everybody wants to know what your transactions per second are. So having that goes a long way towards getting street cred. So transactions per second, connections, index scans, sequential scans, all of that kind of stuff is also good to track. It's pretty easy to get that stuff out of Postgres, and most databases have that as well. There's some way that you can get that information out of them. I've seen people, like if you come from an Oracle background, you get a lot of metrics out of your system, right? You start to get fancy things like cache hit ratio that gets some people really excited. You can put that stuff in there as well. My recommendation, so many of you are probably DBAs or excited about data and think it's at least somewhat important. Don't get hung up on the details of what you're monitoring. This is one where I've seen a lot of debate go into, do I want to monitor something like load? That's a good example. It gets picked on a lot because monitoring load average on a machine, load is really weird, right? It's like sort of this amalgamation of different things where sort of disk is involved and then CPU and processes, and they come up with some magic number that doesn't actually mean anything. And then depending on what operating system you're using, it means something different as well, right? But it can still be fairly useful, right? As DBAs, we kind of get a little hung up on what the details of these numbers actually mean, right? We tend to be very strict about our data. We want to know what it means and that it actually maps to something real world that we can calculate and tune. But I think if you get hung up on that, you're doing yourself a disservice, right? I tell people it's better to have something useful than something accurate when it comes to monitoring. And you can always go back and sort of fine-tune your monitoring later. But if the only monitor that I could put on a machine was load, I would start with that, because load is at least a good indicator. If I go over 10 on this box, let's say, I know that the site fell down last time. So I've got an alert I can do, and I can graph it, right? And that might not mean anything outside of the context of that box, but it gives me some direct context as to when a problem might occur, right? So, I mean, I'm not a huge fan of load as being the ultimatum thing, because it really depends. Your load could go over 10 in a different way. Maybe it's this time, or it's memory that time, and resolving it could be different. But as long as you have some way that you can turn what you're monitoring into an actionable item, I think there's value in having those monitors there, right? And if you can come up with better ones, as you go along, that's fine. Get rid of the old ones. I'm cool with that. But don't get hung up on the details of what you're actually monitoring. At a simple level, think about the idea of having these monitors in place and getting these metrics will certainly help you do capacity planning. Capacity planning is kind of something we don't talk about a lot as a thing to actually do. We notice it in our daily lives occasionally, let's say, maybe less so than we used to, but there you go. So, this is actually a live screenshot. Yeah, so, I mean, capacity planning is a good thing. You can get known for being bad at capacity planning, let's say, right? So being able to do those kind of projections, again, it's one, don't get hung up in the details of what you're monitoring and how accurate it is when you're going forward, right? If you can project your numbers out for 6 months and say, well, we get this much disk based on the growth we have now, we'll be out of disk. Well, don't ignore it for 6 months. Go back and look a month from now and see if that projection still holds up. But you don't have to be super accurate, right? You just need to know ahead of time before things hit the fan, before this happens. The other big part about having metrics is as you trend that information, it really helps you know what a good situation looks like. As a consultant, I go into a lot of places where they're like, we'll go and jump on a machine for the first time, and we haven't seen it, and they describe some problem. And so we'll look at numbers, right? We'll look at, you can look at load and say, well, oh, load is 20 on this box. Well, you don't know that that's good or bad, right? It really depends on the workload in the box that you're on, whether that actually makes any difference. But if you show me a graph, right, where here's over the last year we've been trending load, and it's only been over 20 in the last month or so, right? Now I've got something to work with. Because now I automatically know, oh, well, it's normally at 5. Now it's at 20. I can clearly see that something has happened in the last month that has caused your load to go way up. Now I've got a direction I can go in on forensics, right? And that's a huge part of having these monitors in place and being able to do the trending, is that you have the ability to go back and figure out where the change points are and narrow down your windows of problems that you're looking for, right? Answering the question of why your site broke. If you're a DBA, you know you're going to get blamed anyways, right? So you just sort of should assume that that's going to happen and then make sure you have things in place to, if you can't go back and figure out what the problem is, at least, go back and figure out the problem was on the web server or something, right? Like, the box didn't just suddenly spout up like 1,000 connections all of a sudden. We actually had more traffic coming in, and that's what happened, right? And those actually can be hard things to figure out, right? Somebody could go onto a machine and run a query that takes a lock, and now you get a flood of connections coming in, right? And that looks like a traffic spike from the database's side. We had a bunch of connections and it spiked. So figuring out what the cause of that is, right? Well, you need to graph web servers and then try graphing locks on your system, right? And then if you have those two, it's very easy to figure out which side of the problem you're on. So you want to be able to answer this question as much as possible. Also, when you're setting up, trending and collecting metrics, if you can get this into your system, and some packages do this better than others, but being able to track changes into the environment is definitely a huge thing. And by changes, that can be anything from a config setting, right? People doing code pushes of the application, looking at traffic spikes and seeing how that affects things. You want to make it really easy to correlate changes in the environment to events that are going on within your system. If you have those graphs in place and you can overlay them, that's sort of the fancy way, but at least get them side by side and look at the time, something to help you find those patterns, right? We're pretty good as pattern matching machines if we can look at the patterns next to each other, right? Once you have this as well, make sure you expose these to everyone. It's another classic mistake I see in a lot of shops that are moving into the DevOps thing. And maybe even some of you are in a place where system administrators have access to like Nagios and Cacti or something, right? And they're the only ones that do. So nobody else can actually see the graphs that are going on, and nobody else can actually understand the environment and what's happening. And if you're in a place like that, fight against the idea that that's okay. You really need everyone to have the capability to see the graphs and see what's going on, right? And I'm pretty open about, I would say anybody in the company I don't really have a problem with, right? The number of web hits that you get on your site, I guess could be considered proprietary information, but I'm pretty comfortable letting most people know that. And I think that's pretty valuable. So once you have those graphs in place, right, the obvious thing is use those to make your decisions, right? Being able to make decisions based on actual evidence, it's pretty good. It's not a horrible thing. And as people that like data and like to play with data and seeing what it can turn up, like that fits really well into our wheelhouse, right? sort of real life example of one case where this is how obvious it is, right? That this is a good idea, right? So this is a graph from one of our systems, and the orange lines that you see are SVN pushes, right? Pushes out to production. And so one day before lunch, a dev, he's walking out to lunch, and he's like, well, I committed this change. I don't think it's going to cause any problems, but I just thought I'd let you guys know. We're like, okay. And then, so we start watching, and then you can see on the graph, right? Like suddenly, load starts going really high in this box. It's like, this is a little weird, what happened? And so then, it was almost only by accident that he had actually said, he said it as he's walking through the room and nobody's really paying attention to him, right? And I don't want to say he did it on purpose, but, but anyway, so we only didn't really hear that. And we're like, didn't he say he committed something? So then we go back and we can look at the graph and say, oh, that's when he pushed it. And within minutes, like, hey, load starts going way through the roof. And so we were able to show him this graph, and we showed him the graph, like, right about here. And he's like, well, that change shouldn't have caused any problems at all, but, I'll roll it back. That's what you want to do. That's fine. So then we see where he rolls it back, and it's, like that, like the problem goes away. It's like, so clearly now we don't have to deal with you anymore, right? Go fix your code. We know that it was a push that you did that caused this problem. And, it's not to pick on the guy, although I don't have any problem doing that, but the point is that it was really easy to resolve the problem. Right? Like, it was really easy to see it, and anyone could go back and say, oh, this wasn't just the database acting weird. As much as databases have black magic inside them, they are also made up of code, and they tend to just kind of run if you leave them alone. Right? It's when you start injecting change into your environment that things can happen. It's not that developer, actually. I'm not going to say he's never done it either, but this particular case, not that developer. So, I mean, hopefully, like I said, this is a pretty obvious example, but there will be other things like this that you can see. And even this one could save you, we didn't have to argue, right? It was like, we could clearly see, once we could show him that after your commit, the load went high, there wasn't much argument on, can you at least like try to roll it back and let's see how that works? And then once he tried it, it was, very obvious. So, it saves you sort of fighting with your coworkers, and that's a good thing. So. The next big thing that they talk about in good old DevOps land is the idea of doing the pushes all the time, right? You hear this like sort of continual deployment, pushing all the time, like you got to push code, that's the big thing. Doing a bazillion deploys a day, that's how you're a really good DevOps shop. You can tell based on the number of deploys you're doing. And there is some method to the madness, right? It's sort of this idea that, I have an idea on what would be awesome in my site. And if it takes me more than 15 minutes to get it out into production, like I've probably, I might have killed the idea. So I have to get it out there as fast as possible. And, there's upside to that capability. It's really nice when you do have an idea to be able to get it into production really quickly and to not have a lot of barriers in your way. And so I don't discount the, desire to be able to do that quickly. But there are some downsides as well, right? Believe it or not. And the big thing for the folks in this room is that doesn't work terribly well for databases. When it comes to code, code is one thing. Databases are kind of different, right? And a lot of times people try to manage databases just like they manage code. And that's not entirely a bad thing. There's a lot of code that can go into your database, especially if you're doing like stored procedures. It's very much like application code. And sort of having an understanding of how that stuff works together is definitely good. But there is sort of the one big fundamental difference that I've found when it comes to databases and application code. And that's that databases actually have data in them, right? And data is sort of a very different thing than code, right? It's a different beast. For one, it's actually important. And not to discount, application developers, but data is really one of the hearts of your business in most cases, right? And to the degree that it's important, it's also very hard to actually replace data, right? If you lose your data, you can be in trouble. I would say you can always rewrite the code. Application developers don't necessarily agree with that, and they say it's a lot of work, and I would agree with them, but at least fundamentally, if you don't like the code you have, you can start over and just make a whole new project, right? And this might be a really bad idea for your business. If you're Netscape, you might go out of business, but you could rise from the ashes with a whole new code base. And that's cool. So it can be done. But you can't always get people to give you their data again, right? That's a fundamentally different thing. And if you don't believe me, ask the guys at Magnolia. I don't know how many of you know the Magnolia story, but basically they didn't have backups of their data. They had a catastrophic server failure, and then the next day they had a sign on their website that said, we lost all the data, and we're basically going out of business. They were like a social bookmarking site, like Delicious, right? And so they could have started the service over again, but they would have been starting from scratch, right? And basically said, well, all those bookmarks that you had in our service, hopefully you had them in Delicious, and we'll import them for you. But if you had them in Delicious, you're probably just going to use that from now on. You know, I mean, you're stuck if you lose all of your data. And so this sort of makes data a different beast, right? I would say additionally, when you're comparing the idea of managing code and managing data, keep in mind that code is static, right? Once you write the code and you push it out on your web server, or you compile it and put it out as an application, for most people it doesn't, Turing completeness aside and Feder doing his tricks, like for most people, the code is going to be the same code 3 months from now, 6 months from now, a year from now. It will just be there and it'll keep running and doing the same thing. Code is very controlled, and we have the ability to control it in ways that you don't with data, right? Data is very dynamic. In most cases, especially if you're running sort of large-scale web operations, control is really in the hands of the users, right? How many times they access the data and how much data they put into your system, is usually not up to you. You have basically written a service that says, hey, put as much in or get as much out as you want. Even on internal applications, I don't really know of too many internal applications where you actually limit the number of requests from people inside your company to your application. Right? Like, oh, sorry, you looked in the phone directory 5 times today. We're not going to let you look again. Right? That is kind of a foreign concept for most internal applications. So when you get all of this, what it kind of boils down to, right, is that the idea that the database administration is a little more difficult than code administration, right? And so code development is a different thing, but when it comes to actually being able to manage code and administrate code in machines, it's a different beast to do it with data, right? And it would be nice to say, well, just don't make any changes to your data, right? That's kind of difficult. Some people have a luxury that they're very controlled changes of when data comes into the system, right? Every night you're going to get some nightly dump that you load into the system, and that's all there is. And the rest of the day, it's just read activity. But even in the case of read activity, you don't control how many reads are going on, right? The places where you actually control the amount of writes and reads into a system are few and far between, right? I would almost say they don't exist because I'm a consultant and those people don't have to call me. But for the rest of you out there, it's hard to imagine that scenario. So if you can't eliminate the change, obviously the next best thing is, well, you've got to try to manage the change. And managing change has sort of given rise to, let's say, friction within the technology industry, right? If you go back a number of years, and I would guess that most of you don't live in this world, but maybe some of you do, was the idea that DBAs used to live kind of in these walled gardens, right? You had a database team that you would try to communicate with, and a developer would send the requirements into the database team, of what they thought they needed for their application. Time would elapse as they would do whatever smoke and magic they would do. And then as a DBA, you send the schema back to the developers, right? And you've sort of thought through everything that needs to occur in an application. You've mapped it out relationally. You've looked at how it's going to affect the database physically. You put a lot of effort into the schema, and you deliver it back to developers, and you're like, awesome, like I'm enabling workflow, and I'm doing good stuff. And then, as soon as that's happened, because you're taking your time to do the job correctly, because you're the one that does the job correctly, you're not a developer. But as soon as you send them that schema, then the first thing that they're going to do is send you the modified requirements, right? Like, it doesn't matter how fast you turn that schema around. By the time you hit send and it gets electronically delivered, somebody has decided they need it to do something just slightly different. And so they give you these modified requirements back, and again, time elapses. And so now you go and you send them a new schema, right? And this sort of process should go back and forth as you're working on things. And they send you requirements, you send them schema, you try to work it out. They're sort of push and pull on how to get things done. Devs sort of get excited, like, I actually have a deadline I'd like to meet, and you guys are dragging me down. They just want to get things done. You're trying to sort of minimize, right, disruption and instability when it goes to production, because you actually are responsible for something. It's not enough to just say, like, I have a pretty drop-down list on the website if you would just only put them in production. Like, you actually have to keep it running going forward, right? So anyways, eventually the struggle goes on, and you'll agree to something, right? And that will get put out. But it takes a long time. And like I said, it sort of leads to this tussle between different groups within the company, right? And sadly, a lot of ways shops respond to this these days, is they just get rid of the DBAs. Unfortunately, we're generally outnumbered when it comes to the tech department, right? I don't know too many places that there are more DBAs than there are devs, right? And the CFO doesn't actually look at the data through P-SQL, even though it is the best interface ever to a database, right? He's looking at the pretty website. And so the guy who wrote the pretty website is the guy he's probably going to keep around. And so I see a lot of shops go that route, and I'm sort of like, well, that usually leads to bad things. And mostly because even if you get rid of the DBA, it's not like your data went away and you don't have to deal with databases anymore, right? Even if you go into a NoSQL environment, there's all kinds of data stuff that has to occur, right? You actually might have to build indexes or do compaction or all kinds of other things. So somebody still has to deal with that. And so if you find yourself sort of in this position as a company that's transitioning and you're a part of that, try to sort of get all zen about it, I guess. Find your balance, get the inner peace going of working with developers and whatnot. And so the best processes that I've seen sort of follow along this model, right? And so nobody throw anything now. So what we tend to do is, we actually have our developers design the schema. And I see Nasby's not here, so this is good, because he will definitely throw things at me. So for most people, that's a scary idea, right? Having your developers write schema, you say, that is not going to work. Like, I've seen what happens when that happens, and it's not good. But the way that I've sort of looked at this, in most cases, your developers are actually meeting with project managers, and a lot of times with sort of the end users, right? And I don't want to say, DBAs aren't as bad as like system admins when it comes to lacking the ability to do social interaction, but just in most cases, the workflow is going to be developers are talking with the end users to figure out how to make things, interact. Because they get those requirements, they're the ones that have to digest them and interpret them into what we need the application to do, right? So they understand the app better than you do in most cases, right? And if you don't think that that's true, a lot of times, you'll have to go back and ask questions when you're designing schema about, well, how do you plan to query this data, right? The fact that you have to ask that question means you don't really know what the app is going to do, and you got to ask someone. And you expect the developer to give you an answer, and they might really not know what the answer is because they don't know how to write queries. But like that's where you have to find the common ground. But really, you can see that the core knowledge has to come through those people, right? So devs understand the apps, have them write the schema, and let your job just be, I want to be available if you have questions on the schema that you're writing. And this shouldn't be a really foreign concept even to the developers, right? Some developers might push back and say, like, I don't know how to write schema, I don't know how to write queries, like, I'm not going to do this, right? But it's no different than any other technology, right? Whatever kind of shop you're in, unless you're like a one-man shop, you probably have somebody that knows more than the other guy or the other gal. It's Ada Lovelace Day, sorry. So that knows more than the other gal about what you're writing and the technologies that you're using. And there's questions that go back and forth when that occurs, right? So as a DBA, you're the senior dev when it comes to database stuff, right? You understand queries and how to make them work. And so when there's complicated stuff, they should be able to ask you questions and then you help them. It's best when you help them learn how to do it, right? Then it cuts down on the questions going forward. You can shortcut some of that stuff, right? Make a style guide for how to write schemas. Tell them that it is absolutely an atrocity to actually put a bare keyword ID column in your table. Like, that's horrible. We don't want to do that. I'm not seeing a lot of love for that idea, but I'm telling you, it's a bad idea. But come up with naming standards. Like, do you want plural names and make everybody's life tough, or do you want singular names on your tables? It sounds pretty, sort of silly in a lot of ways, but how many times have you heard developers arguing over tabs versus spaces, right? We've been doing that for like 50 years now, and that one's still ongoing. And clearly tabs are better, right? So it's like, if they can argue about that, if they can argue about that for years and years, then you can argue about plurals versus singular names, and you shouldn't feel bad about it, right? So make a guide for schemas. Have schema changes become migrations, right? When you need to put a new piece of code out, and it's going to rely on changes to the database, that should be coded up as to what is the actual changes that you need to occur, right? A migration should have both new schema that's going to happen and what's going to change. And you should be able to review that in total, right? All migrations should be subject to review. And it doesn't necessarily have to be you. If you have good developers on your side that actually know data, because some things will be really simple. We need this new column to store data, and we're going to make it text. you're like, okay, that sounds good. Like, that you don't need a lot of review. There's not a lot of overhead to that. But make sure all migrations can be reviewed, right? And make sure the more complicated ones are reviewed. You want to look for red flags when you're doing these migrations, right? I would say things like, are they using nulls? Are they putting indexes where we think that they're needed, right? What are the data types they're doing? What kind of constraints are they putting on? And when I'm looking at these kind of things, the thing that I'm most looking for really is sort of what is the impact of doing these changes going to have in production, right? And most critically, at the point of putting them into production, right? Because the stuff that devs really don't know and probably don't need to know is all this sort of nitty-gritty bits, right? Understanding the locking. If I change this varchar 12 to a varchar 10, is that going to require a rewrite of my entire table, right? And so I don't require a dev to actually know that. I will figure it out for them, right? Because I'll know what version of the database we're running and where that actually matters. And then if it does, I might push back and say, we can't actually do this because our database software is dumb. We need to upgrade the database software to actually make this not be a pain. So we have to figure something out, and it'll probably make things more complicated. But that's the kind of thing you want to be looking for, right? And so once you get into that mindset, right, you're not busy writing schema all the time and writing little one-line alter table statements, right? You can push some of that work back into the devs. They'll get a better understanding of how things go, and you get a pretty good workflow going at that point, right? You're still in control of when things go out to production, and that's sort of important. The idea of doing 1,000 pushes a day doesn't really work for databases, right? That's not the goal of what we're trying to get to. And mostly I would say that goes back to the locking problem. As Bruce had said in his talk earlier, if you saw it, right, nobody likes locking. And I would say that people actually do like locking when building applications, but when you're putting code in production, definitely nobody likes it there. It makes things very tough. So to have the sort of understanding that, you have peak times in your application. Even if you're a 24/7 shop where you have thousands of transactions a second, in the day you have 20,000, in the night you have 10,000. So now you've got a window there where you can say, maybe we should do it at nighttime, Build those schema migrations into sort of the off-peak hours of your business. And I don't necessarily care when that is, right? Off-peak can mean a lot of different things to a lot of people. You might actually want to say, we only do schema changes once a week, right? So that might sound restricting, but you should probably know a week ahead of time anyways if you're going to make a change to your production schema. I don't think that's too much to ask. For some people, maybe you can do it once a day. That's not so bad either, right? If you know, well, if we do it in the morning, there's not a lot of activity, that's fine. We have one client that's like, we can do changes to the database anytime we want, we just can't do it during lunch, right? And it's not because they all leave the office for lunch, it's because that's the peak time of their traffic, right? At noontime, traffic goes way up like that, and then it tails off. And by the end of the day, we can restart the database if we want to. It doesn't matter. So the thing is, like, you can't eliminate risk, right? So you're going to have to push this stuff out there. Locks are going to be taken. Disaster is, just a step away. But you can at least minimize the amount of risk that you're going to take, right? You can look and make sure, well, do I want like 10 alter tables in one transaction? Well, you probably don't, right? You probably want to break those up into their own little thing. And speaking of that, I think it's also something I want to mention. A lot of people don't tend to think about this, is that if you have multiple schema changes or you have schema changes that are supposed to go with code, there's no reason that you actually have to tie those things together, right? Just because you need a new column for some new piece of code doesn't mean that you actually need to wait until the code's ready to go to put the column in place, right? Once you know the column's going to have to be there, feel free to put that column in at any time you want. Adding a new column, this week instead, and just don't write data into it, hopefully shouldn't hurt anybody. If you're doing a lot of select stars, maybe you got to deal with that. But even in those cases, it's pretty rare where that really breaks anything. So add columns well in advance of writing to them. If you're making a new table, you can put that in just about any time. That doesn't really matter. If you're planning to drop a column, there's no reason that you have to drop the column right after the code is stopped, right? Have somebody write the code to not use that column and let it sit there for a few weeks. Make sure you don't actually need the data anymore, then drop the column. And in Postgres, dropping columns is really simple. So, you don't even have to really actively go back and clean it up if you don't want to. It's a quick operation. So there's a lot of sort of advantages to disassociating your schema changes, with the time of code deployment. It doesn't have to be all done at the same time. I think also a part of that is that when you're doing development, if you've ever worked on a project and had somebody send you like the big monster patch, right? Like those can be hard to sort of work your way through all the different pieces. So schemas, I think, are easier if you can do small incremental changes, right? If you know, well, when we do this code change, it's going to touch like 10 different tables, but I can do like these 2 column changes this week, and I'll do like 3 more this week, and then we got the 5 that we have to do at the end. But being able to slowly roll that out makes a lot less impact on your production system. DevOps, I mean, it's kind of a new way of thinking. There's been a lot of talk around it, over the last couple of years. It's starting to pick up more steam. I think when you look at DevOps, and if you're in a shop, like I said, if it's starting to transition in that way, realistically understand that, in my view, DBAs were the original DevOps, right? Most of us have to write code on one hand and manage production on the other. So we sort of have probably had a role where we have one foot in both worlds, right? And it's only like the devs now, like the idea of a dev carrying a pager, right? Having a web guy with a pager is crazy, right? Or having sysadmins that actually have to use Subversion to check in a config file. That seems to be a new idea, right? But DBAs have pagers and write code into Subversion like all the time. Like that's not a crazy thing. You can easily find yourself in that situation. So don't be scared of that idea, right? As the original DevOps folks, go to it, look at both sides of the equation, see what people are trying to get, and then help those teams put those things together and figure out the way that it works best, to help you do your job as well. Thanks. Photo credits, just in case you need them. In case you need a voodoo donut, it's in there. Yes, sir.
Actually, I have more of a tip.
Uh-oh.
One thing I'm trying to do that I didn't mention, have a staging system that has a full copy of the production database. Well, quite a number of migrations work perfectly well with a reduced size copy of the database that do not work with the full database.
It's definitely best. Yeah, I mean, the closest you can get migrations to production is definitely good. There's definitely industries where you can't do that. And that actually, I mean, if you're in like healthcare and you're trying to be DevOps, like you have a really hard time of doing that, right? Because you either are playing fast and loose with some of the rules and regulations that are there, right? To actually give everyone in your company a copy of production data is a little bit iffy. You probably shouldn't be doing that. So it gets harder in those environments. But yeah, I would definitely say the closer you can get people to doing things looking like production, the better off you'd be. Yep.
You gave an example of trying to make schema changes sort of ahead of time, ahead of code changes. Have you seen any conventions maybe where you indicate like the type of schema changes? Because it seems like that's really excellent for new data and really screwed up for actual like moving data. Like if you add, maybe if you add a new column, certainly if you add a new table, that's cheap and easy and okay to do. But in working with like a lot of developers or where you're seriously outnumbered by developers, how do you kind of like have flags of like this might be the type of thing that can go ahead of time or this can't, or do you just manually review everything?
Yeah, I think most of the places where we do it, it's manual review, and then over time people start to understand the differences, I guess, right? A large part of this is actually, it is educating developers on things that they should be aware of. And you can actually, I mean, we have like wiki pages where it's like, here's things that are going to be big no-nos, right? Like if you're doing a default with a not null, or a default on a new column that you're adding, or things like that, where it's like, they don't really need to know the inner workings. They just need to know, oh, if I'm adding a default someplace, then this is going to require something, right? And so as long as they have in their head, this could be a potential problem. They don't necessarily have to be able to work out how to get it in there. But having them understand the cases it will be bad and educating people to that, is sort of huge. And then once both people understand that this could be a problem, then it's usually not that hard to work something out, right? And it's usually management doesn't have a big problem if you say, well, if we add this with a default, it's going to rewrite the table. Like I've actually seen more DBAs have a problem with saying, we're not going to put the not null default in there. We would if we were doing this from scratch, but we have a running system. More DBAs will have a problem with dropping that constraint than developers would, right? Or than management would. And if you just realize, well, schema purity actually is not as important as taking my site down for like 2 hours so I can like add a table with a not null default, right? Like if you can get over that hump, then everybody else will probably be on board with the things you're trying to do. So, yep.
We've developed a process already, Nova, still not as smooth as it could be, but we never take the site down.
Yeah, and that's sort of key. And it, depending on version or type of database software that you run, these problems are easier or more difficult. Oracle for a very long time, as much as people rag on it, I mean, you have the ability to add constraints that are not necessarily verified, right? And so, yeah, there's potential that your data could be a problem there, but you can usually verify that in a non-obtrusive manner, right? Like I can do a select on the column, and it doesn't actually block anything, and realize whether my data is clean. So, I mean, that's coming in Postgres. Like they seem to finally be getting up with the idea that, hey, being able to just say, if you can stop future stuff from being what I don't want it to be, I will go back and clean it up, and I'm comfortable with that. As those capabilities come in for Postgres land, like it'll definitely be easier to do that stuff. But yeah, all that kind of things where adding the column without the default, and then you go back and do some process that slowly goes in and fills the data in, right? And having people be aware that that thing is going on. It definitely requires communication amongst the team when you're doing that stuff. But once you have the processes in place, it's usually not that hard for people to follow them. So, it's like anything else with development. Like you tell people to check in code. Like the first time you introduce source control into a place, if you have 10 developers, like 9 of them are going to be really excited, and there's going to be one guy who like forgets and he still wants to go do the change in production because it's awesome. And if that guy's like the founder of your company, then you have a lot to deal with. But and for most people, it's not that tough. I mean, you get on board with that, and that's just the process, and you follow it. Any question?
So yeah, you've got like developers submitting schema changes. And I've thought about this. I haven't found a solution. So you get 2 different schema changes that could potentially conflict, or certainly have to be applied in the right order, or what have you. Are there any tools or systems out there that deal with that problem, or is it still kind of down to a smaller subset of humans figuring that out?
I like to do it with humans, so I find them to be good tools.
Well, yeah.
So yeah, I mean, I've used a few products that try to do like big diff things and all that, but I think there's no like distributed schema, like conflicting resolution tool that's out there, right? Even like source control stuff won't really do that for you. And even when you look at like migrations, consider the SQL that you're writing to get the stuff into production is actually not, like what a PG dump would output. So it's not the final product. So there's really a mismatch there. And I haven't found anything that people actually like to use that works well when you start scaling up past, more than 2 or 3 people. So we use humans for that. And I don't think that's all that bad. I mean, there's source control review tools, right? But you don't leave that as an automated process in a lot of places, right? You still like to have somebody else look at the code. So, and this is not really that different from that. So. All right, no more questions. Well, I'll run away. Sounds good.